Hi everyone. Now I will discuss the projectile motion from motion in a plane. In this projectile motion, we will discuss the ground to ground projectile motion and height to ground. Similarly, projectile motion on inclined plane and some problems we will discuss. Okay. I will divide this projectile motion into two parts. Now in this lecture I will explain projectile motion part 1. This questions only related to the JEE mains questions I will explain. In the next video I will explain regarding the advanced level questions also. Okay. First, ground to ground projectile motion. Ground to ground projectile. Okay. In this case, let us consider that this is the x-axis and here y-axis is there. I am taking this is x-axis and y-axis. A particle is projected with certain velocity u, making angle theta. Now you can see that it will take this kind of a path, parabolic path it takes. Whenever it is taking parabolic path, we can observe that what is its total horizontal distance covered by the body r, and what is the maximum height reached by the body h, if it is started from t is equal to 0 at point A and reaches the B in time. That time is what? A time of light. We are going to write the relations between t and h and r also. I am writing relations. I can write the relation of time of light. Time of light, we can write t is equal to 2 into u sine theta divided by the g. Same thing you can write like this also. The horizontal component I am taking as ux and vertical component I am taking as uy. You can see how these ux and uys are there. Okay, ux and uy values are there, no, that you can see. Ux is equal to u cos theta. Similarly, uy is equal to u sin theta. And as g is acting downward direction, no acceleration along x-axis, ax is equal to 0, ay value is minus g, as my x-axis and y-axis is vertically upward direction is there. Same thing you can write 2uy divided by the g also you can write, otherwise magnitude of ay. This is the time of flight. We can see our time of flight is this. T is equal to 2u sin theta by g or 2uy by ay. Next, we can see horizontal range. Horizontal range. Horizontal range is r. It is maximum horizontal distance covered by the projectile. Okay, it is maximum horizontal distance covered by the projectile. This range r can be written as ux into time of flight, or you can write it as 2 into ux uy divided by the g. You can write the same thing. You can write it as 2 into u square sin theta cos theta divided by the g. You can write the same manner. We can write u square sin 2 theta divided by the g also you can write. The first relation 2 ux uy by ay is this one I am writing in other way. Instead of writing g, I am writing magnitude of ay. Okay, this is my range. Horizontal range formula is this. We can apply as per the given situation. Next, maximum height. Maximum height h. This can be written as h is equal to u square sin square theta divided by the 2g. Same can be written as u y square divided by the 2 into magnitude of ay. This is maximum height relation. You can use this maximum height relation. So 3 points I have given in this ground to ground projectile. If you want to calculate any other relations like a velocity at any time t, velocity at any time t, you can use the relations Vx is equal to ux plus ax into t. As ax value is 0, we can write it as Vx is equal to always ux only. So you can say that along horizontal direction, velocity is constant. Okay, similarly along y-axis I am writing. So if you write along y-axis, velocity along y-axis at any time t, if I write that Vy value is equal to uy plus ay into t, you can write uy minus g into t, as ay value is equal to minus g. You can see here as time passes Vy value changes. So you can say that along y-axis, first body retard means speed decreases, okay, then accelerate. Meaning is from point of projection to maximum height, speed decreases, then from maximum height to ground, speed increases. You can see here overall I can say that in projectile motion, if you take any projectile motion, in this projectile motion, if any particle is moving like this, you can observe that it is projected with a velocity u. It will have the components of velocity like a ux, similarly here uy. Now if you take at any point, it will have like a vx and vy. At highest point we can see that its velocity ux is equal to vx only, and the vy value is 0 at highest point. And similarly vx is equal to everywhere ux only. You can see vx is equal to ux everywhere, but vy value will change everywhere. Similarly whenever it is striking the ground, so it will strike with the same velocity, it will strike again, same velocity it will strike. Here uy value, here ux value will be there. Same velocity meaning is same speed is same, okay, but if you observe that velocity direction is changes, okay. Why? Because initial velocity is u bar is equal to, you can write it as at t is equal to 0, u bar is equal to ux I cap plus uy j cap is there. At t is equal to time of flight, final velocity v bar is equal to, you can write it as ux I cap minus uy j cap is there. See the observation properly, its velocity changes but speed is remains constant, okay. Along x-axis its speed is same, ux is same, but uy value you can observe that from t is equal to 0 to highest point, you can observe that velocity is actually having upward component of velocity and horizontal. Now while coming from maximum height to ground, you can see whatever velocity is there along the direction of the acceleration. As you know that whenever velocity is opposite direction to the acceleration, you can say that body retards. Retarding is nothing but body speed decreases, okay. If velocity and acceleration both are same direction is there, body accelerates. body accelerates, or we can say that body speed increases. Okay, observe this carefully. Along x-axis constant velocity, along y-axis it is first retarding then accelerating. Okay, meaning is constant retardation, constant acceleration is there along y-axis. And other than this, if you want to see that time of ascent, time of ascent, time of ascent you can write it as time to reach maximum height, time to reach, time to reach maximum height. This time to reach maximum height, you will get the time of ascent is equal to half of the time of flight. That value is uy divided by the g. Also you can write it as u sin theta divided by the g. Also you can write this is the time of ascent value. Okay, more details regarding this projectile motion only you can see. Now whenever a body is moving from or projected ground to ground, in that case you can observe that if you want to calculate at any position which is located at x-axis x and y is y, its velocity is v. Now you can see if it is making angle alpha, now you can write vx is equal to ux, and vy value you can write it as vy is equal to uy minus gt. If you want to calculate angle at any point, alpha is equal to tan inverse of vy divided by the vx you can write, or alpha is equal to you can write as tan inverse of uy minus gt whole divided by the vx is nothing but ux. That is a velocity vector making with x-axis. Okay, and if you want to calculate x and y, you can write position of the particle at any time t, at time t, at a time t, x is equal to ux into time taken t, and y is equal to we can write uyt minus half into g into t square here. Okay, now if you substitute this t value here, x divided by the ux value, if we substitute, y is equal to uy divided by the ux into t minus half into g divided by the ux square into x square. Okay, t square can be written as x square by ux square is that I have written. So from these details we can write it as tan theta. What is a tan theta? Tan theta can be written as uy divided by the ux. Now substitute there, u is equal to tan theta into, I wrote one mistake here, t is equal to here x by ux, no? So tan theta into x minus we can write it as g divided by the 2 into ux square into x square you can write. Okay, this can be written as y is equal to ax minus bx square form is there. Now you can see what is a value. A is equal to tan theta and b is equal to we can write g divided by the 2 ux square, provided ux is equal to u cos theta. Okay, you keep in your mind this equation is a parabolic equation, so you can write it as a parabola is a path. If they ask like a trajectory equation, this trajectory equation is nothing but the equation of path traveled by the projectile, equation of path traveled by the projectile. Here path is parabola. You can see that parabolic path. The relation you can see y is equal to tan theta into x divided by the g divided by the 2 into u square cos square theta whole thing into x square. The same value you can write x tan theta into 1 minus x divided by the r, where r is a range of the projectile. R is a range of the projectile. R is range, horizontal range is there, no? That R is equal to 2 ux uy divided by the g term is there, no? That we can write here. Okay, you can remember this expression. Sometimes they may ask to compare this ax minus bx square form they will give. Just they will ask what is ux value and tan theta value, angle of projection and all. Okay, you can refer these points. Next point. Sometimes in exam they will ask that what is a range for two different angles. Okay, I am drawing that two angles here. Let us consider a particle is projected with an angle theta. If it is traveling an angle theta, the range can be written as u square into sine 2 theta by g. U square sine, range is having so many formulas. I am writing u square sine 2 theta by g. If I project with 90 minus theta, this time also if I project with the same u, I can get the value of range is equal to, in first case r1 I am writing, second case r2. U square of sine of 2 into 90 minus theta whole divided by the g. So this value r2 also you can write the u square sine 2 theta divided by the g only. So it indicates that R1 is equal to R2. When R1 is equal to R2 will be there for complementary angles. Complementary angles. Complementary angles. In sum of the angles should be 90. Sum of the angles is 90 degrees. For complementary angles, range is same. Range is same. What are the complementary angles? Like a 20 degrees, 70 degrees. Next one set 45 degrees comma 45 degrees. Now you can see that 30 degree is 45. I would like to neatly 45 degrees comma 45 degrees. Next 30 degrees comma 60 degrees. Similarly you can write it as 40 degrees comma 50 degrees. Like different sets you can write. Okay, range is same. All these ranges will be same. If two projectiles are projected with the same initial velocity with complementary angles, range will be same. Okay, you can observe that. If any problems are there more related to the maximum height and time of flight in that cases, we can compare the relations. Okay, next one, horizontal projectile motion. Horizontal projectile motion. Horizontal projectile motion, we are seeing that otherwise you can say that instead of writing horizontal projectile motion, I will do one thing, projectile motion from certain height. Projectile motion from certain height. Certain height above the ground. Above the ground. If you write the projectile motion from certain height above the ground, how these values will be there, you see here one by one. First case I am projecting like this with velocity u, projected height h. Okay, if any body is projected horizontally like this, we can say it is reaching to the ground. Now you can see the range, whatever range is there, that is r. What time will be there? Time of flight is or time to reach from height to the ground is t can be written as root over 2h divided by the g. That is the time of flight. And the range value, range can be written as r is equal to horizontal velocity u into time taken t, that u into root over 2h divided by the g. For every problem we have to see this ux value. Here ux value is equal to u, uy value is equal to 0, ax value is 0. Here ay value is equal to, downward direction is there, minus j I am taking, as it is x axis and y axis. I am taking here x axis. Point of projection I am taking as a origin. Okay. From there if you see that we can get the time of flight and all. If you want to calculate velocity at any point, you can write the velocity also, and you can write vx is equal to every time ux only, and vy value will get the g into t. At the same time, if you want to calculate alpha, tan inverse of, you will get the vx divided by the vy value. So it implies alpha is equal to tan inverse of Vx is nothing but Ux only, divided by the Vy value is Gt. This is the angle made by the velocity vector at any time t. Similarly, sometimes they will ask what is the displacement from the starting point to ending point. Suppose if I say that this point is B and A, so AB is R, and if you want to calculate OB value, you can write under root of h square plus range square, we can write that is the displacement of the particle. And path of the particle, if you want to calculate, it is a trajectory, is a trajectory of the path is a parabola. Trajectory is parabola. So you can see here, this projectile motion also called horizontal projectile motion. Horizontal projectile motion. This name is horizontal projectile motion. If you want to calculate velocity whenever it is hitting the ground, that also you can write horizontal velocity is Vx is equal to Ux, and while dropping here you can see it will touch the ground with root 2 gh. That is my Vy value. Okay, we can calculate that Vx and Vx and Vy value at any each and every instant you can calculate. Okay, next one, we can see next one is if they project the any projectile in other than the above case, like this. I am not telling you to remember any formulas, but basic relations are there. No, this you can remember. Whatever I have written here, time of flight, range relations are there. No, that you can remember or derive as per the situation also. These are the basic formulas. Every case you will get. That's why you can remember that. Next one. Here, if any particle is projected with velocity u making angle theta, x-axis and y-axis I have taken, origin is this, h is the height. In this case, particle will go up and again it will fall down. Okay, similarly, I am taking one more particle down like this, u making angle theta, x-axis, and upper one is upward direction is y-axis. Now particle will go like this and hit the ground. Now height is the same height is there. This is a range in this case, and first case range is equal to r. In both the cases, if you want to calculate anything, you just write the ux value, uy values. Ux is equal to u cos theta, uy value is equal to u sin theta. Similarly, ax value is 0, ay value is equal to minus 0. In next case also you can see ux is equal to u cos theta and ax value is 0. Uy value is equal to, you can write minus u sin theta, as it is downward direction is there, and a y value is equal to minus z. As per the situation, we can calculate the time of flight and all the terms we can calculate as per the given relation. To find the time of flight, use y is equal to uyt plus half into ay into t square. Here y is equal to minus h, uy value will write, t value will write minus half into g into t square. So we have to use this relation, find time t. Next, to find range r, you can use the formula r is equal to, means x is equal to, you can write it as x is equal to ux into t plus half into ax into t square. As ax value is 0, we can write x is equal to ux into time taken t, that is equal to range. In both the cases, whatever the values are there, you can substitute and get the answer in this case of projectile motion. Okay, suppose say in the if it is inclined plane is there, projectile motion on inclined plane, projectile motion on inclined plane. So first case, up the plane. I am taking, there is a projectile is projected on up the plane like this, making angle alpha. U is projected with an angle theta. Now you can observe which is my x-axis and y-axis. This is parallel to plane is x-axis, perpendicular to plane is my y-axis. Okay, let us consider this is the point A. Now this particle will take this kind of path and reach, okay, on the plane like this. If you want to write the all the terms I am writing, at any instant if you want to calculate the G is actually downward direction. If it is this angle is alpha is there, perpendicular direction, you resolve this into the components. Y-axis and x-axis is like this. Now you can make this other directions also, right? This is 90 minus alpha, blue color I have written, this is 90 minus alpha, this will be alpha. As it is perpendicular direction, we can see G, you can resolve, this is G cos alpha, and another component we can write G sin alpha. Similarly, along x-axis you can write this is ux and this value uy. Okay, I am writing data ux is equal to u cos theta, uy value is equal to u sin theta, a x value is equal to minus g sin alpha, a y value is equal to minus g cos alpha. These are my equations. By knowing initial velocities and accelerations, you can calculate any kind of like velocities or displacements along x-axis, y-axis, maximum height, everything you can calculate at a given time or a given location. Okay. Now in this case, if you want to calculate time of flight, let us consider the particle is reaching to the B. Okay, like landing on the inclined plane at B. In that case, how to write? I am writing now. To find time of flight, I am not writing remember any formula, just I am writing to find time of flight. We can write AB vertical displacement value is equal to 0. So I can write y is equal to 0. We can write uy into time of flight plus half into ay into time of flight square is equal to 0. From this we can write u 2uy by ay magnitude value is equal to time of flight. Now according to our relation, uy value is equal to much u sin theta divided by the magnitude of ay value is equal to g cos alpha. This is my time of flight. Similarly, if I want to calculate range AB along x-axis, okay, that is I am writing r. Now I can write x is equal to ux into time of flight plus half into ax into time of flight square. Just you substitute the t values here. Don't try to remember this formula. Okay. Similarly, if any problem, if they give like any particle is just striking the like this theta is projected, if it is normally striking, nothing but v x value is equal to much 0. If vx is equal to 0, you can write ux plus ax into t is equal to 0. We can calculate what time it is striking normally. Okay, this kind of questions we can observe. If it is parallel to plane is there, y value is 0. Based on the conditions we can follow that. Okay, next one, down the plane. If it is down the plane is there, now I can write the alpha. Now you see a particle is projected with u making angle theta. If it is projected down like this, I am taking this is the A and landing at a point B. Now again I am taking this as origin. My x-axis is like this and my y-axis is like this is there. Now if I take the components, this is u cos theta, ux is there and uy value is like this. Similarly, if I take the g values, I can resolve into components as it is 90 degrees, 90 minus alpha and this value is alpha. We can write the g cos alpha and along this line you can see G sin alpha. G sin alpha you can write. Otherwise you can do one more thing also. X-axis you can change as per the situation also. If I take my x-axis is along this line, you see here this is x-axis and my y-axis is like this is there. Okay, you can change. Okay, throughout the problem you can follow the same manner. U x is equal to, I can write the u cos theta, u y value is equal to u sin theta, a x value is equal to g sin alpha, a y value is equal to minus g cos alpha. Okay, if you want to calculate time of flight, same thing, 2uy divided by the magnitude of ay, you will get the 2u sin, so whatever the earlier value is, 2u sin theta divided by the earlier also same value got g cos alpha. This is our time of flight. To find range, for range r, you can write the ux into t plus half into ax into t square, you can write, substitute the value. Okay, by this way you can calculate the range in this projectile. Okay, now I will give the one more thing, how to calculate the maximum range values also will write. Okay, finding maximum range. Finding maximum range. Let us consider a particle is projected ground to ground. If it is projected ground to ground with velocity u, and I have taken x-axis and y-axis both are perpendicular. So x-axis, y-axis both are perpendicular. In this case, to get the maximum range, every time you have to project a particle with bisecting angle. Okay, now you can see u and x and y-axis is 90 degrees is there. If you project particle with bisecting angle, range will be maximum. Range will be maximum. Here r maximum value you will get the u square divided by the g. This is my maximum range. Okay, and it is at theta is equal to 45 degrees only, you will get this. If you want, you can check the theta is equal to 45 degrees value, you will get the sin 2 theta value is equal to how much? 90 degrees. Sin 2 theta is 90 degrees. Sin, 2 theta is 90 degrees, sin 2 theta is 1 you will get. Okay, so you can get the at theta is equal to 45 degrees, range is maximum. Okay, similarly same thing you apply for the inclined plane. In case of the upward inclined plane as well as a downward inclined plane, both the cases I will write, you can see. This is alpha inclination is there. I have projected with a certain angle, I should get like a maximum value. For that what I am doing is, you just observe that this is my plane. That plane is this is x-axis, this is a horizontal, this line whatever I have written vertical. Okay, now if I project any particle with velocity u, alpha, already alpha is this angle is equal to 90 minus alpha. Now my projection particle is I have to project a particle with a bisecting angle. Which is a bisecting angle here? Bisecting angle with vertical and plane is 90 minus alpha divided by the 2. Okay, that is my theta. For maximum range I am writing, for r maximum, theta should be, projection angle theta should be equal to 90 minus alpha by 2, that is equal to 45 degrees minus alpha by 2. Similarly, you take the down the plane condition. If I take the down the plane condition, if I project any particle like this with u, okay, now you can make the, so I will draw the properly. If I project like this with u, okay, now I am making a vertical line as well as a horizontal line also, you can see. As per the question, you can see this is my x-axis and this is my vertical line. Why? Because along vertical line means downward direction, G is there. Okay, now I am going to observe that only. This is alpha, my U value is like that is there. Now you can see remaining angle, how much this angle is equal to, you can see this angle is 90 degrees. Okay, now total angle, if you see, the value is 90 plus alpha is there. Now my projection is there. Now this is the projection. This should be bisecting angle. What is the bisecting angle here? This bisecting angle to get the maximum range. What is the bisecting angle? 90 plus alpha divided by the 2 is equal to theta. I am writing for maximum range, projection angle theta should be equal to 90 plus alpha by 2, that is equal to 45 degrees plus alpha by 2. So sometimes they may ask that in up the plane, down the plane, what should be the angle of projection theta to get the maximum range. Okay, just you substitute this theta value in the whatever r value we are getting now. Earlier I have written in this case what is the r value, uxt plus half axt square is there. No, just you substitute there, you will get the maximum range. I hope it is clear for you regarding this projectile motion, just basic concept. Just I have revised this all. Okay, now we are going to apply these concepts to the problems. See here, a boy can throw a stone up to a maximum height of 10 meters. A boy is throwing a ball. Maximum height means he is throwing a ball like this. Okay, now his velocity is u. Ball can reach the maximum height of 10 meters. You know, h maximum value is equal to u square divided by the 2g, that value is equal to 10. Now maximum horizontal distance that the boy can throw the same stone, nothing but if we throw this ball with certain angle theta, what maximum range he can throw. To get the maximum range, we can see that for r maximum, the theta value should be how much? 45 degrees. So r maximum value, you know that u square divided by the g. You substitute there u square by g, from above relation you can write it as 20 meters. So here also you will get the 20 meters. Substitute there, third option is the correct option. Next question. Two guns A and B can fire bullets at speed 1 km per second, 2 km per second respectively. From a point on horizontal ground, they are fired in all possible directions. All possible directions means we can see that if you throw any ball from here, we can throw like this, like this, like this, like this. In all possible directions we can throw all these balls. No, it can take like this, like this, like this. So in any direction it can go like this. Okay, it can go like this, like this, like this, like this. Any direction it can go. Okay. Now the ratio of the maximum areas covered by the bullet fired by the two guns on the ground. As you know that whenever the particle is going, so just I am taking any one of the projectile. So like this, if you take any projectile, now you can see area, how much area it is covered. You have to take the, it is a parabola now, you cannot write simply pi r square or any other value. Just you take at x distance, there is a y element I have taken. That element is having like a dx is the thickness. Now area of strip is, I am writing like a area of strip. Area of strip is, means actually I am dividing this parabolic, under the parabolic is, you know, that region I am taking, dividing into small strips. Okay, one of the such strip is having at x distance, y height is there, that area is dA is equal to, I can write it as y into dx. As you know, y is equal to uyt plus half ayt square is there, no? That relation you apply that. Or similarly, y is equal to tan theta into x minus g divided by the 2u square into cos square theta into x square relation is there, no? Even you can apply that. So I have done that, actually you can see it. I have used that. With time I have written, if I apply the same relation just to calculate the area under the trajectory is maximum. I have done this with one time period. I got the relation area value is this much. A is equal to 2v to the power of 4 by 3g square sine cube theta into cos theta. Okay. Now, if I want to calculate the maximum area, to get the maximum area, I got like theta is equal to 60 degrees. Okay. You can also try this. Okay. You take the screenshot and you can try this. Okay. And A maximum value, I got the root 3 v to the power of 4 by 8g square. In the question, they are asking what is the maximum area. Maximum area proportional to v to the power of 4. Okay. Now I am going to use this relation. You just observe this. Okay. So I am going to use that. Here also, what is the area integral of y dx? Y is equal to u sine theta into t minus half into g into t square into dx term is there, no? That dx term you can write. X is equal to u cos theta into t is there, no? U cos theta into t you can write, and dx is equal to u into cos theta into d theta. That relations you can write here. As I wrote already here, you can check that how it is there. V cos theta into dt term is there. You can use that. Okay. If you use these all relation, finally you are getting A proportional to the V to the power of 4. Okay. Now A maximum value. We can write A maximum value A1 divided by the A2 can be written as first velocity is 1 kilometer per second. Second velocity is 2 kilometer per second. Substitute that value. 1 divided by the 2 whole to the power of 4. We will get the 1 by 16. My suggestion is don't write this as a range maximum. They are not asking range maximum. They are asking area maximum. See, here we have to catch a point. One point is maximum area is maximum area of a path is not maximum pi r maximum square, where r is a range. It is not range. Kindly keep in your mind this. It is not this. You have to follow this manner and calculate the area. Okay, I calculated here. If you want, we can go through this in one time period. What is the area? Kindly observe this carefully. In JEE Mains exam, this much no need to do. Just you will get the V to the power of 4. But don't write the V square. Actually, range square term. Don't write. Okay. I will get the option 4. Okay. Next question. A plane is inclined at an angle alpha is equal to 30 degrees. With respect to the horizontal, a particle is projected with a speed u is equal to 2 meter per second square from the base of the plane, making angle theta is equal to 15 degrees with respect to the plane as shown in the figure. Distance from the base to at which the particle hits the plane, means they are asking just range value. As I told earlier, I am not going to remember any formulas. Okay, just I am using the basic relations. Basic relations only I am going to use. U is equal to 2 meter per second. This is a theta 15 degrees and alpha value is a 30. How much is a 30 degrees? Now whenever it is projected like this, we are going to calculate AB value. Okay. In this AB value, we can resolve into components. What are the UX? UX is equal to 2 cos 15 degrees. And uy value we can see that 2 sine 15 degrees. Now I can see what is my g values also. I can see g is downward direction is there, as making is 30 degrees. We can write the this is also 30 degrees, as it is 90 degrees, it is 60 degrees and 30 degrees. Okay, g cos 30 degrees, and along x-axis you can write g sine 30 degrees. Now my x-axis and y-axis, this is x-axis and y-axis. I am writing the relations. Ux is equal to 2 cos 15 degrees. Uy value is equal to 2 sin 15 degrees. Similarly, Ax value is equal to minus g sin 30 degrees. Y value is minus g cos 30 degrees. Cos 30 degrees. First, to calculate the range, I want like a time of flight. Time of flight is 2 uy divided by the magnitude of ay. 2 into uy value is 2 sine 15 degrees divided by the ay value is g sine 30 degrees. You calculate this value. Next, for range, r is equal to, I can write it as uxt plus half into ax into t square. Just substitute the t values here. Okay, sine 15 degrees, sine 30 is 0.5, it will come approximately 0.25. Okay, I have taken this values, you can see here 0.26, cos 15 is 0.96. Use that relations, I have calculated the value, I got the value is 20 centimeters. Okay, use that, sine 15 is 0.26, 0.96. Okay, I use that, sine 15 degrees is equal to 0.26, cos 15 degrees is equal to 0.96. Use this, you are getting 20 centimeters is the answer. Observe carefully, I have not remember anything. Time of flight is basic relation that I have written. Okay, in vertical, whenever the particle is projected vertically up also, you have used that only. We have used the same formula. Next question. A shell is fired from a fixed artillery gun with an initial speed u such that the target on the ground at a distance r from it. If t1, t2 are the values of the time taken by it to hit the target in two possible ways. Okay, observe this carefully. According to question, the target is fixed here. This is my target. I am projecting a particle with different angles. One angle like this is a, okay, same velocity, and another angle same velocity I have projected. Other angle should be 90 minus theta to get the same range. Range is same. Okay, to get same range, angle of projection should be complementary. Observe this carefully. This is the main point to solve the problem. Okay, now I am writing range. Anyway, range is same in both the cases. First case, t1 is equal to 2 into uy by g, u sin theta divided by the g. t2 value can be written as 2u sin 90 minus theta. Sin 90 minus theta divided by the g. That value can be written as 2u cos theta divided by the g. This is my t2. If you multiply the both t1 into, why? Because they are asking t1 into t2. t1 into t2, we can write 4u square sin theta into cos theta whole divided by the g square is there. But if you write the range formula, we are getting like a 2u square sin theta cos theta whole divided by the g. I told range I have given different relations. U square sin 2 theta by g, or 2u square sin theta cos theta by g, 2ux uy by g also you can write. From this you can write that t1 into t2 is equal to 2u square by g value you can write it as r. So I can write it as 2 into r divided by the g extra is there. So you can see 2r by g is the value. Second option is the correct option. Okay, next. The trajectory of the projectile near the surface of the earth is given by the y is equal to 2x minus 9x square. You observe with the trajectory equation. Our trajectory equation is there now. trajectory equation in ground to ground. Y is equal to tan theta into x minus g divided by the 2 into u x square is there, or u square cos square theta whole thing into x square is there. Now in place of tan theta we are having 2. If tan theta is 2, options they have been sin and cos. So you can write sin theta, tan theta value is equal to, you can write it as 2 by 1. If you make a triangle, you can get the theta 2 by 1, hypotenuse will be root 5. So sin theta value will be 2 by root 5. Cos theta value is equal to 1 divided by the root 5. So now you check that what are the other values. G divided by the 2 u square cos square theta is equal to, they have given 9 as per the question. Okay, it is 9. G is 10 divided by the 2 u square into cos square theta value is 1 by 5 is equal to 9. So from this you can write it as u square value can be written as this is 5. 5 and 5, 25 is there. You can write it as 25 divided by the 9. So u value is equal to 5 divided by the 3. So they have given u is equal to v naught. So v naught is equal to 5 by 3. Third option is correct option. Cos theta is equal to 1 by root 5. V naught is equal to 5 by 3. Just comparison of trajectory equation. This is the main point in this question. Trajectory equation. Okay. Next one. Two particles are projected from the same point with same speed u such that they have the range r but different maximum heights. Now I am taking two particles. One particle is projected with u making angle theta. Now in this case the height reached by the body is h1. Now second case, second particle is projected with the same projection angle, but to get the same range we have to project with complementary angles. In this case the height we are taking as h2. Okay, in first case range is r, second case also range is r. Now I can get the value of this h1 is equal to, I can write it as u square sin square theta divided by the 2g. h2 value I can write as u square sin square 90 minus theta whole divided by the 2g. Finally we will get the u square cos square theta divided by the 2g. This is my h2 value. If I take the r value, r can be written as, in both the cases I can get the u square 2 into u square sin theta cos theta whole divided by the g. If I write the r square value, I can get the 4 u to the power of 4 sin square theta cos square theta whole divided by the g square is there. Now if we substitute the my h1 value and h2 values, I can get the r square value is equal to h1 into h2 value. If you write that u square u to the power of 4 sin square theta cos square theta is there. Now you can write the 4 and 4 is 16, h1 into h2 value will get. Okay, this is the relation between the r and h1 h2. We can write r is equal to 4 root over h1 h2 also we can get. Okay, so from this second option is the correct option. In 2019 they have asked this, we can check. Same manner they have asked in 2022 also. Look here, assertion reason type question. Now maximum height and r ranges they have given to get the for different angles range is same range, and r value you are getting like a 4 into root over h1 h2. So correct assertion is correct only. Reason h1 h2 product value is equal to u square sin square theta by 2g u square cos square theta by 2g. You substitute here also h1 value and h2 value. If you see that, we are getting that only, nothing but assertion is correct and the reason also correct. Okay, r is the correct explanation for a. Next question. The projectile motion of a particle of mass 5g is shown in the figure. The initial velocity of the projectile is 5 root 2 meter per second and the air resistance is assumed to be negligible. The magnitude of the change in momentum between the point A and point B is what? As I told earlier also, how to calculate what is a velocity. while giving the important points I have given. It is 5 root 2 making angle 45 degrees. We can write it as this value is 5 and uy also 5 will get. Okay, whenever it is hitting the ground with the same velocity it will hit. So you can see 5 and here also 5 value will get. Okay, what is a change in momentum? Mass is given 5. The change in momentum is how much here? This is the vx and this is vy, and here also uy and ux values are there. The change in momentum can be written as change in momentum delta p bar is equal to m into final velocity vector minus initial velocity vector. As final velocity vector and initial velocity vector, if you write delta p bar is equal to mass is given 5 gram. Okay, substitute there 5 into 10 power minus 3. Final velocity is 5 I cap minus 5 j cap. Initial velocity vector we can write it as 5 I cap plus 5 j cap. Now you can get the 5 into 10 power minus 3, 5 I cap get cancelled, minus 5 j cap minus 5 j cap will be there. So we can write it as 5 into 10 power minus 3, 10 power minus 3 into minus 10 j cap. In magnitude value, if you write this value is equal to 50 into 10 to the power of minus 3, value is 5 into 10 to the power of minus 2 kg meter per second. You check that as per the question it is 5 is there. So required answer is 5. Change in momentum. Next question. A bomb is dropped from a fighter plane is flying horizontally to an observer sitting in the plane. The trajectory of the bomb is what? Suppose if you take that there is a plane. From this plane a person is sitting here, and this plane is moving with it is moving horizontally, let us consider that, and a ball is dropped. Whenever ball is dropped, no, it will also move along with the horizontal direction and it will fall down. Now you see this observer A, here observer B is located. With respect to observer A in the plane, path of whatever he dropped, path of bomb is a straight line. Okay, it is falling like this, you will feel. With respect to observer B, who is on the ground, path of bomb is a parabola. Path of bomb is a parabola. Now they are asking observed by the fighter plane, observed by the observer sitting in the plane, trajectory straight line. So answer is 1, option 1. Okay. Next one. A player kicks the football with an initial speed 25 meter per second at an angle 45 degrees from the ground. What are the maximum height and time taken by the football to reach the highest point during the motion? Highest point during the motion is nothing but, we can say a ball is projected with velocity u is equal to 25 meter per second making angle 45 degrees. What time it reaches to the maximum height they are telling. Maximum height means this is only maximum height. To reach from here to this location, we can see time of ascent value is equal to uy divided by the j. Time of ascent. Okay. Now this is a starting point. It is a time of ascent point. Now time of ascent value we can write it as u is given ux is equal to 25 cos 45 degrees. uy value is equal to 25 sin 45 degrees. Sin 45 degrees is 1 by root 2 is there. Just substitute there. 25 by root 2 divided by the g is equal to 10. You can get the 25 means 2.5 by root 2. Okay, you can write as 2.5 into 0.707, like that will get approximately will get 1.77 seconds is the time of ascent. Similarly, what is maximum height? Maximum height can be written as uy square divided by the 2g. You substitute there, you will get the 15.625 meters you will get. Second option is the correct option. Okay. A helicopter is flying horizontally with a speed v at an altitude h as a drop a food packet for the man on the ground. What is the distance of the helicopter from the man here? What is the distance of the helicopter from the man when the food packet is dropped? Okay. Now you assume that a man is standing here and there is an helicopter when food packet is dropped. Okay, when he catched, not that, when food packet is dropped, let us consider v is given, height is given. Now food packet is going this kind of a path and finally reaching him. Now if you see that whatever gap is there, this is the ranges are. Okay, we can say range r is equal to v into root over 2h divided by the g. Now what is the distance between the helicopter and a man? You can see this is a distance. Okay, this distance can be written as whatever distance s is there, h square plus r square under root is there. Okay, if you substitute the r square value and all, we will get the third option. Okay. Next question. A projectile is projected with velocity 25 meter per second at an angle theta with the horizontal. After t seconds, its inclination with the horizontal becomes 0. If r represents the horizontal range of the projectile, the value of theta is equal to how much? See how they are asking the questions. U is equal to 25 meter per second, making angle theta. After some time t means it is becoming horizontal is nothing but at maximum height. Here at maximum height, whatever inclination is there now, we can see whatever angle theta with the horizontal, after t seconds its inclination with the horizontal becomes 0. Whatever velocity is parallel to horizontal, inclination is 0. This is only main point in this question. Okay, if you do this, what value will get here? As the range is r, you can say up to maximum height r by 2 range will be there. If it is r by 2 range, what they are actually asking, r represents horizontal range of the projectile, then the value of theta is equal to how much? What is theta? Time of ascent at this point is t. Time of ascent can be written as, that is t only they have given, that t is equal to u y divided by the g. What is the uy value? 25 sin theta divided by the g is they have given as 10. G they have given 10. Now what is the range value? Okay, if you write the whatever the range value is there, you can write what is the range value? R is equal to ux into uy, 2 divided by the g is there. You can write the value as 2 into ux is equal to 25 cos theta into 25 sin theta whole divided by the g value is 10. We can write the value is 25 is, we can write as 5 times, and here 2 times is there, so 2 and 2 get cancelled. 125 into cos theta into sine theta, this value is equal to r. Okay, now you can say that you don't want actually you want t and r terms are there, no, that you want actually. Now how to write the relations of this? Okay, sine theta and tan theta is there, just you substitute there and get the relations. Now what I have to do now, r by t value, if I write r by t, or if you want you can write the in all options now t square term also there, you make this t square. T square is 625 divided by the 100 into sine square theta. You write r by t square value. R by t square can be written as 12 into cos theta sine theta whole divided by the 625 divided by the 100 into sine square theta. Then I can get the sine square one time get cancelled. Okay, now remaining value is 12 into 100 divided by the 625 sine cos theta by sine theta is cot theta, and I can get the cancel of 25 25 is and 4 times I can get. Okay, so this value you can write as cot theta value is equal to, I can write this as 25 r divided by the 4 t square also I can write. Just observe these values anywhere is there. Now you can get the any other changes. 20 and 4 is there, not 4, 12 into 4 is there, no? 12 into 4. Okay, 12 into 4 r into r by t square is there. Okay, you can write it as r by t square. Just observe that somewhere I have written values of this 25 and 48 cot theta value. You substitute that values, not only they have given now. R represents the horizontal range of the projectile, the value of theta is equal to how much? 25 value I have written uy by g u square sine theta cos theta, and by g value also I have written. Just observe that. R value, have I got the 12 sine theta cos theta? Check once here. 5 into this 125, that one 125 you make into 125. Okay, here also 125. Do the calculation properly. 125. Now I can get the value is 25 will be cancelling in 5 times. Now finally I will get the relation as 20. I will add r by t square is equal to r by t square is equal to 20 by I can get the value is cot theta. Okay, 20 by 1. So cot theta can be written as I can get the cot theta value is r divided by the 20 t square. You observe this, fourth option is correct option. Okay, not only this process whatever I am giving actually you can do by your own methods also. Why? Because here so many relations we can write here, maximum height, whatever relations are there now, that relations, time of ascent, y value also you can write if you want to. Okay, do any calculation, but bring expression in terms of the given sine, cos, sine, tan, cot. Okay, I got expression in terms of the cot. Okay, do the calculation properly. Next question. A fighter jet is flying horizontally at a certain altitude with speed 200 meters per second. When it passes directly overhead of anti-aircraft gun, a bullet is fired from the gun at an angle theta with the horizontal. It hits the jet if the bullet speed is 400 meters per second. The value of theta is equal to how much? Now you can see that whenever this flight is here, someone is projected with 400 meters per second. Okay, bullet speed. Now this flight is going like this. Actually it will not actually pointing in this direction. He knows that after some time it will be hitting this. Okay, so you can see it is reaching here. Both the distance traveled will be same, or we can say that horizontal distance, suppose say it is 400 is there, it is making angle theta, we can write 400 into cos theta, and this velocity is 200, flight is 200 meter per second. At this point also 200 meter per second is there. The collision will takes place when horizontal speeds are same. I am writing bullet will hit the fighter jet if bullets horizontal velocity, if their horizontal velocities are same, velocities are same. I am taking this horizontal velocities are same. This is the main point here. We can see 200 is equal to 400 into cos theta. From this cos theta is equal to 1 by 2, theta is equal to 60 degrees. This is our required answer. Okay. Next question. A projectile is launched at an angle alpha with the horizontal with velocity 20 meter per second. After 10 seconds, its inclination with the horizontal is beta. Okay. Here, a projectile is projected with u is equal to projected with alpha. That's all. They have not given what is the value. It is projected with alpha. Now it is going with like this. At any time t, this is t is equal to 0 projected. At t is equal to 2 seconds, body is here. This velocity is given 20, making angle beta. You can see Vx is equal to Ux and this is Vy. Earlier also I have given what is Vx is equal to Ux, that value is equal to U cos alpha. Okay. Similarly, Vy value is equal to Uy minus Gt. I can write Uy value is Uy only, minus G value is 10, T value is 2. Sorry, not 10. T value also 10. Here also I am writing T is not 2, T is 10 seconds. Okay. So I can write Vy value is equal to Uy minus 100. Okay. Again, I can see that what about the V square value? This is what here V. V square is equal to Vx square plus Vy square is there. V square is nothing but 400. Vx square is Ux square. Vy value is Uy minus 100 whole square. I am writing this 400 is equal to Ux square plus Uy square plus whatever 100 term is there, Gt. Okay. 100 whole square term is there. Now you write that 100 whole square minus I can write the 100 whole square minus a square plus b square minus 2ab, 200 into uy. Okay. Now you can see what about the given values here. After 10 seconds is 400 it seems. Okay. You just calculate the relations as per the question. What is the question here? A projectile is launched at an angle alpha with the horizontal with a velocity 20 meter per second. After 10 seconds they have given, no, 1 minute wait, I wrote completely wrong assumption I have taken. Sorry. You see here, it is projected with alpha, u is equal to 20 meter per second. After 10 seconds, t is equal to 10 seconds. Initially 0 is there. Velocity is making angle beta. This Vx is equal to, you can write as Ux only. Now I can write Vx is equal to Ux, nothing but V cos beta is equal to u cos alpha. That value is 20 cos alpha. First relation. Now vy value is equal to uy minus gt is there. I can write the vy value is 20 into sin alpha minus g is 10, t is 10. So we can write vy value is 20 sin alpha minus 100 is there. I got the vx value as well as vy values are there. Now the value of tan beta value is equal to how much? How to get the tan beta? Tan beta value I can write it as Vx and Vy values are there. Vy divided by the Vx. Vy value is 20 sin alpha minus 100 divided by the Vx value is 20 cos alpha is there. Okay, 20 cos alpha means what value you will get here? 20 by 20 is actually 1, no? Tan alpha minus 100 by 20, nothing but 100 by 20 into 1 by cos alpha is secant alpha. I can get the value is tan alpha minus 5 secant alpha is equal to tan beta. Okay, so option is 2. Okay. Next, two projectiles thrown at 30 degrees and 45 degrees with the horizontal respectively reach the maximum height in the same time. Same time means t is equal to how much? Uy divided by the g is there. Same time, what are their things they are asking? So we can write t1 is equal to u1 by g, u1y by g, and t2 is equal to how much? u2y divided by the g. As per the question, we can write t1 is equal to t2. It implies u1y is equal to u2y. u1 value you don't know. u1 into sine 30 degrees is equal to u2 into sine 45 degrees. You calculate that, you will get the u1 into 1 by 2, that is equal to u2 into 1 divided by the root 2. So u1 divided by the u2 is equal to 2 by root 2. We will get the root 2 is the answer. Root 2 is to 1. So root 2 is to 1 is the answer. Whenever you are reading very fastly without reading question properly, sometimes you may get wrong also. Okay, you have to see properly, read the question, take time and read the question. Okay. Next one, the initial velocity of horizontal direction of a projectile is a unit vector, that is I cap. Along x-axis it is I cap, and equation of trajectory they have given 5 is equal to 5x minus 5x square. I told trajectory equation earlier also. Trajectory equation you can write that y is equal to tan theta into x minus g divided by the 2u square cos square theta whole thing into x square. Just substitute there. As per the given question, you can see that g by 2u square cos square theta I am writing as ux square value is equal to, as per the question, it is 5. So you can write 10 by 2 into ux square is equal to 5. We will get the ux value is equal to 1 meter per second. If ux is equal to 1 meter per second, you can get the tan theta value is how much? Tan theta value you got the 5. Tan theta is nothing but uy divided by the ux is equal to 5. So you can get the uy is equal to 5 into ux. So 5 into ux value is 1. So uy value is equal to 5. They are asking y component of initial velocity, 5j cap. That's all. This is only answer. Okay. Some questions, we think that question is easy. Calculation also will be easy only. Sometimes you will do simple mistakes also. Be careful. Next one, a ball is projected with kinetic energy E at an angle 60 degrees with the horizontal. The kinetic energy of the ball at highest point of its flight becomes. So I am projecting a particle with kinetic energy E that can be written as half into m into u square, making an angle 60 degrees with x-axis. Now whenever it is reaching to the maximum height, we can see it will have only horizontal component of velocity, that is u cos 60 degrees will be there. Kinetic energy at highest point. you can write k is equal to half into m u square cos square 60 degrees. Half into mu square value is e, cos square 60 degrees value is 4, 1 by 4. So I can write e by 4 is a kinetic energy at maximum height. So e by 4 is the answer. Next, an object is projected in the air with initial velocity u at an angle theta. The projectile motion is such that the horizontal range r is maximum. Range maximum means theta is equal to 45 degrees. Another projectile is projected air with a horizontal range is half of the range of the first one. So r1 is equal to r, that is equal to u square by g. r2 value is equal to r by 2, that is equal to u square divided by the 2g. Okay. The initial velocities remain same in both the cases. The value of angle of projection at which the second object is projected. Okay. So we can see obviously what should be the values of these range values we can write. Okay. U square by g and u square by 2g is there. When will you get the angle of projection? In both the cases angle of projection is same, or initial velocities are remain same. If initial velocities are remain same, then how to get the angle of projection in both the cases? You project now. First case theta is equal to 45 degrees. Projected range is r. Second case it is projected with certain angle, so that range becomes half of this. Okay. Now if half range is equal to r by 2, you can write it as what should be the alpha value. Let us consider alpha value. To get the alpha value, u square by g is equal to 1 by 2 into u square sine 2 alpha divided by the g. Substitute there, u square by g get cancelled. Then you can write the sine 2 alpha is equal to sine 2 alpha is equal to, you can write it as a 1 by 2. 1 by 2 you are getting. Horizontal range initial case is maximum. Theta is equal to 45 degrees. Okay. So now sine 2 alpha value is equal to how much here? 2. Sine 2 alpha is actually 2 is not possible here. So why you will get 2 here? What I have written? Range r2 is equal to r divided by the 2 is there. Reverse I wrote here. New range r2 is equal to r divided by the 2. That is u square by g is equal to u square sine 2 alpha divided by the g is equal to 1 by 2 into u square by g. You can write u square by g get cancelled. Sine 2 alpha is equal to 1 by 2. Then 2 alpha is equal to 30 degrees. Finally, you can write the alpha is equal to how much? 15 degrees. Okay. So 15 degrees is the answer. Okay. Now, you can see next question. A body is projected from the ground at an angle 45 degrees with the horizontal. Its velocity after 2 seconds is 20 meters per second. The maximum height reached by the body during its motion is how much? A body is projected with velocity, now you have to read the question properly. So ground at an angle 45 degrees. Its velocity after 2 seconds. Now its velocity, it is at t is equal to 2 seconds. Velocity is 20 meters per second. Oh, same kind of question earlier I have written. This angle is something is let us consider alpha. This Vx is equal to how much? Ux. And Vy value is equal to Uy minus Gt. Uy minus Gt value is G is 10, T is 2. So I can write it as Uy minus 20. Okay. Now this value is ux and here uy value is this is u. Okay, I am writing v square is equal to vx square plus vy square. V square value is 400, Vx square value is Ux square, Vy square value Uy minus 20 whole square. Now you can write 400 is equal to Ux square plus Uy square plus 400 next minus 2 into 20, that is 40 into Uy. Now you can see 400 and 400 get cancelled. Ux square plus uy square is nothing but u square only. Now u square value will get the 40 into uy. U square value is equal to, you can write it as 40 into u into sine 45 degrees. Okay. Now you can see that u one time get cancelled. If u one time get cancelled, u is equal to 40 into 1 by root 2. Now you can get the 20 root 2 is the u value. If u is 20 root 2, uy is 20 meter per second and ux value also 20 meter per second. We got the ux and uy value. We need only maximum height. What is maximum height formula? H maximum value is uy square divided by the 2g. Uy square is 20 into 20 divided by the 2 into 10. You can get the value is 20 meters. 20 is the answer. Earlier actually I thought this question they have asked. Okay. All similar models are there now. That's all. In the next lecture, I will continue with the advanced questions, and also I will explain like a relative separation and condition for the collision between the two projectiles. Okay, and the minimum separation, maximum separation between the projectiles. That also I will explain in the next lecture as a projectile motion lecture 2. I hope you have enjoyed this. My intention is I have given the questions. You pass this and do the questions by yourself. Okay. Okay. Thank you very much.